to our second half of the review. The antiderivative of secant of 5x. So our u is 5x, if our u is 5x, our du is 5 dx. So we have to divide by our 5. You're going to have a 1/5 secant u du. Now the antiderivative of secant is natural log secant plus tangent. And I went ahead and just substituted back in my 5x for my u. You don't have to write down your u if you realize it's always just the reciprocal of what's in front of x there. So now for 26, you have one exponential function. When that happens, you will let your u be whatever e is raised to. So x squared plus 1, so du is 2x dx. You want it to match. Here you have an x dx. Here you have 2x dx. So you need to divide by your 2 or multiply by 1/2. So it's 1/2 e to the u du. So your antiderivative is 1/2 e to the u plus c. That's 1/2 e x squared plus 1 plus c. Alright, big idea. The reciprocal of 1 over cosine is secant. So 1 over cosine squared would be secant squared 3x dx. Your u is 3x, your du would be 3 dx divided by 3. So this is 1/3 secant squared u du. You should recognize, what is the antiderivative of secant squared? It is tangent. So tangent of u plus c. So that's 1/3 tangent 3x plus c. Alright, you have the function at the bottom, let that be u. du would be 3. You don't see a 3, divide by 3. So you have 1/3 in front, 1 over u du. Your antiderivative is 1/3 natural log u plus c. So 1/3 natural log 3x plus 6 plus c. Alright, let your u be the exponent. du, this is just a funny looking number. So the derivative is the square root of 5. You don't have the square root of 5, so you divide by the square root of 5 or multiply by 1 over the square root of 5. So 1 over the square root of 5 e to the u du. Antiderivative is 1 over the square root of 5 e to the u plus c. So it's 1 over the square root of 5 e to the square root of 5x plus 7 plus c. Alright, if you have more than one exponential function, you're going to do something else. In this case, if you have a single function on the bottom, you separate it. It's like a warm-up problem we did. So e to the 2x over e to the 2x plus 1 over e to the 2x. These cancel and give you 1. E to the 2x on the bottom is same as e to the negative 2x on the top. Antiderivative of 1 is x. Antiderivative of e to the negative 2x just going to end up being the reciprocal of this guy in the front of e plus c. You can use U-substitution here if you want. u is negative 2x, du is negative 2, so you have to divide by that negative 2. Multiply by negative 1/2. That's where that comes from. Okay, so here u is x squared plus 1, du is 2x dx. I don't see a 2 here, so you divide by it. 1/2 cosecant u du. Antiderivative of cosecant is negative natural log cosecant plus cotangent. Substitute in for your u, so negative 1/2 natural log cosecant x squared plus 1 plus cotangent x squared plus 1 plus c. Sorry about that. So here u is 7x, so du is 7 dx. So divide by 7, so just have it there, so it's 1/7 cotangent u du. Antiderivative negative natural log, no it's not negative, it's natural log of sine of u plus c. So it's 1/7 natural log sine of 7x plus c. So here, U-substitution, u plus x minus 10, du is just dx. So none notice you have this extra x. You have an extra x. You solve for x. So x is equal to u plus 10. You substitute in u plus 10 for your x. So u plus 10, put it in parentheses. And this is just your u to the 10. Distribute, so u to the 10 times u is u to the 11. It's 10 u to the 10. The antiderivative, just use the power rule. Add 1, so you have 12, divide by it. Add 1, 11, divide by it. Last step, plug in your u. 12 plus 10x minus 10 to the 11th over 11 plus c. Alright, this one, if you let u be x squared minus 10, du is 2x dx. You divide by that 2, so you have 1 half u to the 10th du. Your antiderivative is going to be that 1 half u to the 11th over 11 plus c. So you have your u is x squared minus 10 raised to 11 over 2 times 11 is 22 plus c. Alright, U-substitution again. U equals x squared minus 5, so du is 2x dx. Divide by 2, or multiply by that 1 half. 1 over u to the 1 half this time, not 1 over u. So rewrite it. So you have u to the negative 1 half du. Add 1. If you add 1, you're adding 2 over 2, so that's u to the 1 half. This 1 half comes down. Multiply by the reciprocal, so that's multiplying by 2. These 2's will cancel, so it's just the square root of x squared minus 5 plus c. Here, which one do you allow u to be? Well, you're going to pick u as natural log x, because if you do that, the derivative of natural log x is 1 over x, which is right here. Which is 1 over u du. So the antiderivative is natural log u plus c. So it's natural log of x plus c. Alright, single exponential function. Allow u to be the exponent. Du is 3. So divide by the 3. So we have 1/3 4 to the u du. So 1/3 4 to the u divided by natural log 4 plus c. Which gives you 4 to the 3x over 3 natural log 4 plus c. A single exponential function allow u to be the exponent. X squared plus 3. So du is 2x dx. Divide by the 2. Multiply by 1 half. So you have 1 half. And this is 7 to the u du. So like this one, it's 1 half times 7 to the u divided by natural log 7 plus c. So 7, you plug back in your u, which is x. Okay, so our answer is 7x squared plus 3 over 2 natural log 7 plus c. Okay, if we have 1 over tangent is equal to cotangent. So I'm going to rewrite this problem as 2 cotangent 7x dx. These things are equivalent to one another. I haven't taken the antiderivative yet. So the antiderivative of cotangent is natural log of sine. Because there's a 7x here, I need to divide by 7. Or you can use U-substitution. Alright, larger power on bottom. So allow that to be u. So du is 2x dx. Divide by 2. Since you don't have 2x, you just have 1x. So it's 1 half 1 over u du. So it's 1 half natural log u plus c. 1 half natural log x squared plus 64 plus c. Single exponential allow u to be the exponent, x squared minus 4. So du is 2x dx. But you see a 3x here, so divide by the 2. Multiply by 1 half. You can bring out this 3. Bring out the 3 and the 1 half, so you have 3 halves. E to the u du. So it's 3 halves e to the u plus c. Substitute in your u, x squared minus 4 plus c. Alright, u is 3x plus 5. Du is 3 dx. Hey, look, that actually matches this time, so I don't need to divide by anything. This is just cotangent of u, and this 3 and dx are your du. Antiderivative of cotangent, natural log sine. So natural log sine 3x plus 5 plus c. Alright, so our sorry, I hadn't worked this out in class. 43. It's long division. Because you have a larger power on top. So x squared divided by x plus 2. X times what is x squared? X. Multiply across x times x squared, 2 times x plus 2. Now change both signs. So we give a negative 2x. These cross out. X times what is negative 2x? Negative 2. X times negative 2, negative 2x. 2 times negative 2, negative 4. Change both signs. So you have a plus 4. So rewrite this as x minus 2 plus 4, which is this guy, over your divisor, x plus 2. Antiderivative of x is x squared over 2. Antiderivative of 2 is 2x. This is like 4 times 1 over x plus 2. The antiderivative of that is 4 natural log x plus 2 plus c. When you do long division, you have a chain of long problems, or chain of things added and subtracted together. Take the antiderivative of each one and add or subtract them accordingly. Last one, x squared minus 3 is your u, so your du is 2x. Don't have a 2 there, so put a 1/2 in front. 5 to the u du, so the integral is 5 to the u over ln 5 plus c. So 5 to the x squared minus 3 over ln 5 plus c. And you're done. Good luck on the test tomorrow.